Well, you guys were talking a lot. It was kind of pissing me off on my Zoom call.
All right.
I could tell.
Most of my talking was, I don't know what I'm doing, but I don't know how to explain
Slow
that.
Just
down.
shut your mouth and listen. All right. So, okay. So, let's walk through a couple problems here. I want to talk about the arc tangent, arc sine, arc cosine. We didn't even get to arc cosine, so we're gonna do that today. I want to talk about kind of the general idea of what we're doing with these chain rule and do a product rule problem, and kind of walk through. Example, I have 3 problems I'd like to pick out. I'm going to do these really quick. I think you guys are only in here for like 20 some minutes.
Yeah.
58 is that what we're in here too? Like that? Okay.
that's
So,
like
I think so. So we got a lot to cover here in just a very, very short amount of time. So,
Ward provides you back.
thanks.
Yeah.
So yeah, we're in here until 12:55. So, hopefully you guys can see the board, hear me. I'm recording again for those at home. Sorry. So we'll I'll put on the classroom later today. Now, just to remind, we have homework due tomorrow. That's your derivatives. That's what we're reviewing today. We are going to, what was that?
How's your kid doing?
Doing fine. Spent a couple days in the ER. So
Really?
yeah, gasping for breath, terrifying. So. All right, but anyway, so today we're going to be doing kind of the review of the homework that you have due tomorrow. Tomorrow we're going to start reviewing the semester test, 5-day review. Tomorrow, Friday, Monday, Wednesday, or Monday, Tuesday, Wednesday, 5-day review.
Tuesday.
And then the idea is that, I said that, didn't I? And then,
When we get back.
when we get back, Monday we're back because it's like the second or third on the Monday. We'll just use that as like a little mini review day. I'm sure you'll forget something over break. Unless you've been watching the videos constantly to make sure you remind yourself how to do it.
I'll do that.
Do it, rack up my view count, and then the idea is that
famous.
so then the idea is that once we're back on Monday, we'll review anything that you might have forgot, or maybe you watch something from the video that you're not sure of. Then on Tuesday we take the semester test. The practice guide you're going to get in hand tomorrow. So for those at home, I'll just send you one, so you can kind of work on your own, or just put it on a piece of paper or whatnot. The physical copy you're going to get will look identical to the real semester test. It'll just be different problems in those locations. It'll be the same number of questions, same order, everything. You will turn that in the Monday we're back. So when we're back that Monday, January 2nd or whatever it is, you will turn that practice guide in. One more day will not affect you. You've already had it for 2 weeks. You probably should have studied to your heart's content. And then the idea is that Monday you'll turn it in so I can grade it. And then Tuesday we take the semester test. So I do grade those practice guides because there will be certain problems you have to do on your own. There's certain ones that I do. So you'll get some easy points for that. Semester test will be only worth 10%. I could do a max 20, but I went down to the lowest point, 10, because I'm not here. I don't want it to crush your grade, but I also want it to be kind of a boost if you need it. So 10% is the minimum I could put it. So I moved it to 10. I'm going to send out an email again today after school to remind parents of that so they know when my semester test is and how much it's worth for you guys. Your grades will be updated tonight for your semester, the stuff in Google Classroom and all that. I'll be updating some stuff. So if you have any questions, blanks, and whatnot, those all late work will be due by next Wednesday. So next Wednesday, that's a week from today, is when everything is due for Google Classroom. All late work, everything. Because after that, we're just doing the semester testing. Question?
Are those forms like critiqued every point? Because there was a few things I was like, I don't know exactly.
Yeah, so you're gonna wanna probably go back and fix some stuff, so you're gonna have to go back and kind of make some corrections.
You have those in the grade book, don't you?
They're going to be, yes, so all I have to do is hit submit, make sure they're correct, so I'm gonna do that tonight.
So say we look at 90 in this class and we get a 0 on the final, it only drops us down 10%?
No, it's 10% of the overall grade, so it's like your quarter 2 grades, 40% of your grade, or, sorry.
45.
Yeah, 45, and then 45, and then this is 10% of the semester test, so. I don't know what 10% of that would do, you'd have to figure that out. You have to average what you got first quarter and second quarter. There's a chart, you can just type in Google and it'll tell you.
Okay.
So, alright, so let's keep going. We gotta do 3 examples today really quick. I wanna go through these really fast because I only have you for about 20 more minutes. So that way I give you some time where you can actually work on your assignment today or ask questions if you have any, because I'm sure you do. Alright, so here's the idea. Let's talk about the arc sine and arc cosine and arc tangent. Let's do arc tangent first. So let's say this is my function, right? What we talked about yesterday is what these are. These are the inverse functions on a calculator. It's these buttons right here. It's right above the tangent key. We use those keys to find angles, right, on a triangle. When you have your opposite and you have your adjacent side, right? I don't know why I put the theta there. This is opposite and adjacent. You can find the angle that's right here. Because you find these two walls, you divide them, right? Opposite over adjacent. And what you do is you do this arc tangent to it. It's arc tangent, and that will give you the angle. That's what that button's used for. It's just to find an
I
angle.
don't like
We did that back in pre-calc and geometry days.
That's all we do in physics.
So, what was that? That's all you do in
She
physics.
said she hated that. I go, that's all we do in physics.
Yeah, so.
it.
But anyway, that's what it's used for, but when we find the derivatives, because sometimes you have to do that. Sometimes you're looking for the slope at that moment, the exact slope on a triangle type of shape, and you know the angle that's involved. Or you're trying to use the equation to find the walls, the change in the rates of the walls. You could use arctangent to do it. So that's where, like in Calc 1 or Calc 2, they would actually show you like the uses of these like in an actual problem. Today I'm just trying to show you what the formula is so you know how to use it. So the derivative is going to be 1 over. So this is how you do it. You do the 1 over, and then it's 1, is it plus x squared? I think that's what you wrote yesterday. The first derivative. So I believe it's 1 plus x squared. I don't want to type it wrong.
Yeah.
Yeah, 1 plus. So, all right. But that's the derivative. That's it. Now, if there's anything really complicated in the x, something like really goofy, that derivative goes second because it's a chain rule. You always multiply by the derivative the inside later. Question.
So if it's just x plus 1, then I do times 1.
Yeah, this is x plus 1.
Yeah.
So then you take the derivative of the inside, which you're absolutely right, the derivative of the inside is just 1.
Okay.
So that's
That was pretty much a Google form question.
Yeah, so I try to keep them pretty straightforward on certain Google questions where I just want to see if you're paying attention to how to find that derivative, you know, what's the chain rule works and how it's used. You're going to have one of these today where you have to do, you know, like a derivative with arc sine or cosine or something goofy where there's something on the inside you're going to have to do. So I'll make up one later. I'll do it with sine or cosine or something like that. But does everyone understand that arc tangent?
Yep.
Okay, now, if you want to see how that works, I can show you. It's basically doing the same idea we did for the natural number for E and how we proved it. It's where you use inverse functions, and it will actually turn out to be this in the long run. If you guys want to see that, or do you guys just want to move on and just
Move
trust?
Move on.
Moving on, okay.
Trust me.
Okay, next one. Arc sine. This is the new one from yesterday. So, arc sine. Arc sine of x. Maybe just turn my volume down. I don't know if you guys can talk. I don't want to ignore the people that are online.
Is Jake there?
Okay. So arc sine, the derivative of it is 1 over the square root of 1 plus x squared.
That was minus.
Is it minus?
I thought.
Yeah, I think it's mine.
Yeah, I have minus in my notes.
It is
It's
minus.
I'm an idiot. Alright. Oh, Lord. Alright, minus.
Still got rust.
Yeah. Okay, so 1 minus x squared. Now, if the x is something complicated again, whatever this is, whatever that x is, so let's say it was the x plus 1. That x plus 1 will go here and be squared. And then behind it, you'll have to take the derivative of what's in that parenthesis, the x plus 1 and take the derivative of it.
So one.
Well,
Did we do that, Vanessa?
I think so.
Okay.
so, well, I'll do an example of that here in a minute. Maybe I'll do it for arc sine or arc cosine or arc tangent. I'll do something where I'll mix up one where we have something really kind of weird and goofy inside the actual parenthesis. Maybe I'll put like a natural number like e to something, or I'll put the natural log of something, or I'll put another one of these in there. So you can kind of see how that's going to work. Okay? And then the last one, which is the new one, I don't think we've done one of these yet. It's the arc cosine. This is one we haven't done. It is almost exactly the same as arc sine, because sine and cosine almost have the exact same derivatives.
1 plus.
It is the exact same idea, and here's the only difference. There is a minus sign on the top. I know that one for sure. See, it's because if you know sine, the cosine one is the exact same formula. It has the minus sign on the bottom even.
So it's just a
It
negative.
just is a negative. And if you think back to it, when we do derivatives of sines and cosines, they were the same exact idea. They just flip-flopped. One was positive, one was negative. So that's actually the reason why it actually works out the way that it does. It's actually the exact same derivative. It just happens to be negative. Cosine would always give you a negative derivative. Even if you take the derivative of normal cosine, it gives you negative sine. So, kind of a goofy thing when you actually start to see how
What's
this
the
works.
derivative of negative cosine?
Negative cosine, like if I had a negative out here.
Like, oh, that is, never mind, I don't know what I was.
I can do it if you want to, like, if I did just like that. You want to take
Sure.
the derivative of it?
Sure.
Okay, the derivative of this, well, it would be negative, and then the derivative of cosine would be a negative sine. So these would end up being positive. So it's
Just
just
sine.
So it's just sine.
Oh,
So, because negative just hangs out front, you know, that doesn't affect anything.
So a negative arc cosine would just be sine.
Yeah, basically it'd be the 1 over. Yeah. Okay, all right, now, I'm gonna take one of these. I'll give you guys option. You can pick any one of these that you want, arc sine, arc cosine, arc tangent. And I'll just pick something, and I'll put something goofy on the inside. So pick any one of these.
arcane.
Arc sine, or arc sine first. I'm gonna put, let's put like an E in there, just something weird, okay? So let's go with, okay, so arc sine, and let's put like e to the x squared in there, something kind of goofy. So this is my example, how to use these derivatives.
I don't know why, but how you drew that cranked me up.
Can that little camera see that whole whiteboard?
Yeah, I was like.
It's like 170 degrees, right?
Yeah, yeah, I think it is actually a 170-degree angle view. So, yeah, I can just see to here, and I can see all the way past that first frame of the window, the second window shows up.
And
Probably doesn't look normal. It's really, there's a lot of glares in the work where these lights are really.
The lights are
glaring.
horrible.
So, yeah, you can actually see them if you just unfocus your eyes and forth, you can see all the lights. All right,
Oh, nice, that's really cool.
so.
Anyway.
Alright, anyway, the derivative of this. So, first derivative. So we have to follow the normal rules. So it's like chain rule, right? The derivative of arc sine is 1 over the square root, 1 minus, and then whatever's in your parenthesis squared. So the item that's in the parenthesis with the arc sine was e to the x squared.
Times.
So that's the derivative of arc sine, right? But then, like you guys were saying, we have to multiply by if there's something in the parenthesis, right, behind the arc sine. You also have to multiply by that derivative. So what is the derivative of e? E, right? It's e itself. Then, if there's something complicated in that power,
So
Which is
2x.
2x.
that's the derivative of that, which is the 2x. So it's like a chain rule. Derivative of the inside, derivative of the inside, derivative of the inside, you just multiply them all together until you've exhausted where you can't do it any further.
I'm exhausted.
So we're done.
That's it, that's the answer.
What would you do if there was a natural log in there?
Okay, so if it was a natural law,
Let's do another one.
So-
do another one.
So, because there was one in there that was, it was like e to the natural log of x squared or something.
okay, that's fine. Alright, so, if it was so you want one of these arc things, or?
Sure, yeah.
Okay, so let's do arc
Oh my gosh.
tangent of the natural log of
E.
x squared plus 10x. Okay, pick something goofy.
Okay.
You said that so many times. Who's this?
Alright. So, derivative of arc tangent. So we're doing the outside, right? So, I don't know if you can see this. I'll turn it a little bit. There you go. Alright. So the derivative of arc tangent. So we're doing the first derivative. Well, the arc tangent is 1 over 1 plus, and then it's x squared, right? Whatever your parenthesis is squared, right? And so the idea is that whatever's in the parenthesis goes here. Natural log x squared plus 10x. Right? It's whatever's in that arc tangent would go down there. Then you have to multiply by the derivative of this thing.
So 2x is 10.
So yeah, so how we do that, when you take the derivative of natural log, the natural log, it's 1 over that item. 1 over whatever that item is, right? Right, because that's how you do natural log, it's always just 1 over whatever it is. And then obviously we have to go further, so, because we have to multiply by whatever's in the parenthesis of that,
Times 2x.
times the 2x plus 10. That's how you do that problem.
So then you're done.
Then we're done. That's T.
Okay.
Derivative of the inside, derivative of the inside, derivative of the inside. You just keep going until you've exhausted it all. The goofy one, like that we talked about yesterday, this part of the natural log, it's 1 over whatever that item is. That's how you do derivative of natural log. And then if there's anything in the parentheses, you always multiply those in the back. So, yeah, just kind of follow the pattern as you go. I think we've really covered everything. We've done powers. The only thing I haven't done is a product rule. We haven't reviewed any of that stuff yet. Product rule is where you do derivative of the front times the second plus the derivative of the second times the first.
Those get girthy, I bet.
Yeah, it's kind of big. It's kind of big problem. So we can make up one if we want.
That's just the first derivative, it's not as bad. Second derivative.
Yeah, second derivative is the tough stuff. That was that one assignment where it was like just impossibly long. They just go forever. We have to do second
Yeah,
derivatives.
that's what we just said here, Ward. We don't care. Here's our answer.
Yeah.
That's what it was, really.
That's what it comes down to. I remember in college having to do like third and fourth derivatives of like things where they just took forever. It took so much paper to do it. And you just go forever, you're just grinding out a problem, and you're trying to simplify it when you can, and oh my gosh, I remember just spending hours at Movie Time Video, like where I worked in Clear Lake, just working on one problem at the countertop. Just like, God, it just doesn't end.
Yeah.
That's probably an easy job.
It was, I just watched movies all day.
What did you
I
do?
could watch 4 movies a day. Because no one, man, I had like 3 people renting movies
Right.
all day. And I memorized who they were, so I typed in their number before I even got to the counter.
Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday.
All right. Are we good?
Saturday.
Okay, I'm gonna treat you loose. We'll review some more tomorrow. Tomorrow we're gonna start the practice semester test, so for those at home, we'll do the practice guide. I'll send it to you via email so that you have a copy, and you'll just write down a piece of paper. You'll just email that to me when you're finished. Google Classroom will be updated tonight. So if you're missing anything like LI's missing scores, you're gonna see that in JMC. It's pretty easy. All I do is just go back and take the scores from Google Classroom and I enter them directly into JMC. It takes like a few seconds to do it. So that'll be probably done this afternoon if I have a little bit of time. I don't know if I have meetings this afternoon. So, but again, we'll start reviewing the semester test tomorrow, and you'll get a physical copy in your hand so you know exactly what it looks like.